Does your small weather enthusiast brain not know what to look at on radar? Well, in today's video, I'll be teaching you the 3 main products and how to spot a tornado on radar. So where do we get started? We gotta talk about the 3 main products on radar. So this right here, this is a radar. You see it? Yeah, you see. And this radar sends out an electromagnetic pulse. That pulse then reflects off of the raindrop. After that, the radar listens for the radio waves that are just emitted. This is also why we call it reflectivity. Now, I would get into the other products, but that's for another video. And today, we're only discussing what to look at. So this right here, this is reflectivity, and this is the data that the radar gives us. This is basically the intensity of rain, with blue, greens, and yellows usually being light rain, 2 oranges and red usually being heavy and severe. And if you see pink or any colors after that, that's most of the time a sign of hail. And this is very helpful for spotting a supercell or a tornado on radar. Now if we take a look on the May 3rd, 1999 Moore, Oklahoma tornado, you can see this very pronounced hook at the rear of the storm. And in the middle of that ball of reflectivity is where the tornado is. So shouldn't reflectivity be all we need? Why do we have all these other products? I mean, why does the National Weather Service complain about issuing warnings being hard? I mean, it shouldn't be that hard, really. I mean, look at this. This doesn't even really look like a supercell. But yet there's an EF1 tornado that went through Largo and no warning was issued. And radar's range isn't infinite. The further a storm is away from a radar, the lower quality it's going to be on radar. And that's where problems like this come. But this mess up only happened because of bad quality. Can you see how the shape of the storm could be pretty misleading to weather forecasters? And that's where velocity comes in. Now velocity is a little bit more complicated than reflectivity, but once you know the basics of it, you'll get pretty good at it. Think of velocity as wind direction, with the color green indicating winds moving towards the radar and the color red indicating winds moving away from the radar. Take a look at this radar frame from 2024 on the 9th of January. Can you spot where the supercells are? If you pick these 2 spots, then you're right. There's an area of red pixels moving away from the radar and an area of green pixels moving towards the radar, indicating rotation. This is what we call a couplet. Now, couplets can look very different, but they always look relatively the same. So let's define what's not a couplet and what is a couplet. If you see slight reds and greens next to each other like this, that is not a couplet. Don't be going around saying, oh my god, I saw EF5. Oh, now this right here, this is a very strong couplet. You do not want to mess with this. This is the type of couplet that could tell you there is a tornado on the ground. Now velocity acts weird. Sometimes there can be a strong couplet on radar, but no tornado on the ground. And that's why we have correlation coefficient. Now CC, or correlation coefficient, basically tells you how well other things correlate to the shape of raindrops, with rain showing up as a value of 1, or the color pink, orange and yellow being hail, and green to black being debris. If you're looking at a couplet on radar and you start to see correlation coefficient drop like this, that's a sign that the tornado's hitting stuff and throwing debris into the air and the radar's capturing it. Now if you see all 3 of these together, that's most likely a sign there's a tornado on the ground. And boom, you just spot yourself a tornado on radar.